Hello everyone, welcome to the video explanation for Brian Passwater's topic 2-3 notes, example 3. So here on this example, says the selected values of f are shown on the table above. Determine if f could be linear, quadratic, exponential, or none of these. So again, there's a couple things to consider here. First of all, we've already talked in this class about how to find these patterns in a table of values. Remember that first requirement is that the x values increase at a constant rate. So since all of our change in x is always positive 5, that means we have those equal length input value intervals, which is that requirement for us to be able to use the approaches that we have talked about to figure out whether this data in this table, these inputs and outputs, could be linear, quadratic, exponential, or none of those. Now you also need to keep in mind that we have to include the words could be in our answer because these are only selected values of the function. It's not the entire function. We don't know what's happening between these x values. Now remember how these patterns work. If it is a linear function, then the outputs will have a constant addition pattern, meaning that we have a constant rate of change. If it is quadratic, the rate of change will not be constant, but the change in the rate of change, the second differences, will be constant, meaning that the rate of change will be linear. And finally, if it is exponential, then the change in the outputs will be proportional, meaning it will have a constant multiplication-based pattern. So when we look at these numbers, we quickly see that our first differences are plus 2, plus 4, plus 8, plus 16. These are not constant. And as a result, this is not linear. So once we confirm that the initial change is not constant, that rules out linear. Then we look at the second differences. Well, the second differences are also not constant. Remember that if they were constant, that would be a quadratic. So this is also not a quadratic. So now it's either exponential or it's none of the above. Well, the way we tell is we continue to look at the second differences, but instead of looking at an addition-based pattern in that second, in the red numbers, we look for a multiplication pattern in those second numbers. And there is a multiplication pattern. Going from 2 to 4 is times 2. Then going from 4 to 8 is times 2. And going from 8 to 16 is times 2. Which means that while the change in the rate of change was not constant, the change in the rate of change was proportional. Okay, we do have a constant multiplication-based pattern in the rate of change. So this could be exponential. Because the output values have a constant multiplication-based pattern. They are proportional. And it is actually a disguised pattern, so it's a little bit tricky to see. We have to realize that the outputs, there is a multiplication-based pattern there, but again, it is hidden. It actually does not start. Okay, the pattern there is 2 times that number minus 1. And we'll talk more about how to find that pattern in a later set of notes. So that does it for the 2-3 note.